Hello students, in the previous lecture I discussed about what is a biomedical signal, the types of biomedical signal, or you can say the sources of biomedical signal. In this lecture I'll introduce you to the man instrument system. Why do we need a man instrument system? So before actually discussing what is man instrument system, I'll discuss what are the problems that are encountered in measuring a living system or in measuring a human being that has resulted in the development of or in the introduction of man instrument system. So to start with, if we say in engineering analysis, what we do in engineering analysis, we have a system. Suppose we have an unknown system, and to that unknown system we give a certain combination of inputs, and for those combination of inputs we measure the output from the system. We call that unknown system to be a black box. Okay, so we have an unknown system which we are calling it a black box, and in that black box we are giving a certain combination of inputs, and for those combination of inputs we are measuring the output. So what is the result? Why are we doing this? In engineering analysis, why are we doing this to a black box? So that we can learn about the nature and characteristics of that black box. So what is the result of this experiment? As a result, we get a set of input-output equations which will define the internal functions of the black box, and because of that we'll get to learn about the nature and characteristics of the black box. Now we have many black boxes, but one of the most complex black boxes that is conceivable is a living organism, especially living human beings. Why? Because within this black box, that is the living human being here I am referring as, within this black box we can find electrical, mechanical, thermal, acoustical, optical, hydraulic, chemical, pneumatic and many other types of systems, all interacting with each other. And this human being, this living human being which I am considering here as a black box, it also has a powerful computer, several types of communication systems and a great variety of control systems. And to further complicate this situation, if we want to measure the input and outputs from this black box, we'll learn that the input-output relationship of this living human being black box is not deterministic. It's non-deterministic. None of the input-output relationship is deterministic, which means if for a given set of inputs to that living human being black box, the output may vary. The output will vary. It may be completely random, it may be totally unrelated to any of the inputs, or there may be a wide range of responses shown for a certain combination of input. This living black box, it also presents other problems, like for measuring a variable from a living black box, you'll get to see that some of the variables you will not be able to access. So if you want to measure any variable in a living black box, you have to access that variable, but you will learn that you will not be able to access that variable. And as a result, for measuring that inaccessible variable, we have to adopt some less accurate substitute measures. Therefore, moreover, there is a high degree of interaction among the physiological variables in this living black box also. That is, if we want to measure one variable, or if we want to measure the relationship between two variables keeping one variable constant, it is impossible to do so. And the situation is made even worse when we try to apply a measuring device which will measure the variable. The situation becomes even worse. So at first glance, an assignment to measure and analyze the variables in a living black box would probably be labeled as impossible by most of the engineers. So the function of medical instrumentation is to help the medical clinician and researcher in devising ways of obtaining reliable and meaningful measurements from a living human being. So what is the function of medical instrumentation? Is to devise the instruments, is to help the medical clinician and researchers. How? By devising the instruments so that meaningful measurements, or you can say reliable and meaningful measurements, can be obtained from that living black box. Even if the instrument has been devised, or measurement, the medical instrumentation field has given the methods of measuring, or the instruments for measuring the physiological variables from living human being, still there are other problems which are associated with such measurements. That is, the process of measuring must not in any way endanger the life of a person on whom the measurements are being made. So, in the similar way, there are various additional factors that add to the difficulty of obtaining reliable and meaningful measurement from a living black box. So, in this lecture, I will be discussing about what are the problems that are encountered in measuring a living system. So the first is inaccessibility of variables to measurement. So one of the greatest problem is inaccessibility of variables to measurement, which means, suppose if you want to measure any variable in a human body, for measuring that variable you need a transducer, or you need a measuring device. So in most of the times it is impossible to place a suitable transducer in a position so that the measurement can be made. For example, to measure a dynamic neurochemical activity in the brain, that is, for measuring dynamic neurochemical activity in the brain, we need a transducer. And many a times it has been seen that it is impossible to place a transducer in the required place for the measurement to be made. Why we cannot place the transducer? The reason may be either the physical size of the transducer as compared to the space available for the measurement, that is, the required physical size of the transducer as compared to the space that is available for the transducer to be placed. You getting my point? The space that is available for the measurement in where the transducer is going to be placed. So the required physical size may not match the space that is available for measurement. And the second point may be given to the medical operation. Even if you have devised a transducer according to the space requirement, that is, if you have devised a transducer according to the space requirement where you're going to place the transducer in the human body, you have devised a transducer, but the medical operation that is required to place a transducer may lead to the whole measurement to be impractical. Risk factor is there for the living body. So in that case, what we say, we cannot access the variable that we want to measure because we are not able to place the transducer. We are not able to devise the transducer, and even if we have devised the transducer, we are not able to place the transducer in that position so that the variable can be measured. So how the measurement of that variable can be done? Then we have to adopt some substitute method. So we'll go for indirect method. So in indirect measurement, what happens? This process, it involves measurement of some variable which is related to the actual variable under interest. The variable, the inaccessible variable that we are not able to measure, what we will do, we will measure some other variable which we will measure some other variable, and that variable is actually related to the variable under interest, or the inaccessible variable under interest, you can say. So in that case also, in indirect measurement, even we have measured some other variable which is related to the inaccessible variable, we need to know the limitations of the substitute variable, because we need to determine when the relationship between the two variables is not valid. There might be certain point that the relationship between the two variables is not valid. So this is the first problem of obtaining measurement from a living system, that is inaccessibility of variables to measurement. The next problem is variability of data. Now, few of the variables in the human body that can be measured in the human body are truly deterministic variables. But most of the physiological variables can never be viewed as strictly deterministic variables. Means, if you want to measure a physiological variable under a fixed set of conditions at one point of time, the result so obtained may not match the result done under those similar set of conditions but at another point of time. What I am trying to say, if you want to measure a physiological variable and you have measured the physiological variable under a fixed set of conditions at one point of time, the result may not match with the measurement of that physiological variable under those similar fixed set of conditions but at another point of time. So what is this? This is variability of data. And the situation even get worse when the variability from one subject, even if you have obtained the result of the physiological variable, means from one subject you have somehow measured the physiological variable which was giving variability of data, and you have measured that physiological variable by performing that statistical analysis. So by performing that statistical method, so you have obtained the data from one subject, but the situation gets worse when the variability from one subject to another is even greater. That is, physiological variable obtained from one subject, from one living being, may not match the measurement of the same physiological variable from another living being. So there is variability of data. So what will you do here? Again, statistical methods must be used to estimate the variable or to measure the physiological variable. The next problem that has been encountered in measuring data or in measuring a living system is lack of knowledge about interrelationships, which means in the previous two cases I have discussed about inaccessibility of variables to measurement, and the second one is variability of data. So what is happening, as I have told you in the previous case, variability of data, that one physiological variable is giving variation of data at different points of time. So why there is variation of data? This variability, this foregoing variability in the measured values of the physiological variable could have been better explained and understood if the relationship among the various variables within the human body is better understood, means there is a high degree of interaction among variables in the human body, and if those high degree of interactions or the interrelationships between the variables among the variables within the human body have been known, then this foregoing variability of a physiological variable would have been better explained. Moreover, this better understanding of physiological relationships would also have permitted better use of the substitute method or the indirect method or the indirect measurement method for measuring the inaccessible variable. As in the first case I have told you that there are certain variables in the human body which you will not be able to access, and for measuring those variables we have to adopt the indirect measurement method, and in the indirect measurement method we have to measure some variable which is related to the inaccessible variable under interest. So this indirect method have been effectively used if the better understanding of the physiological relationship or the high degree of interrelationship among the variables in the human body have been known. Moreover, because of this lack of knowledge about interrelationships, or you can say about the interrelationships among the various variables in the human body, the physiological measurements with large tolerances are often accepted by the physicians. So because of this knowledge, because of the lack of this knowledge, what is happening? Physicians are accepting large tolerances in the physiological measurements of a variable. So these were the three problems that has been encountered in measuring a living system. Rest of the problems I'll discuss in my next lecture. So in the next lecture also I'll continue with the same topic, that is problems encountered in measuring a living system, which has led to the development or the introduction of the man instrument system. So I'm ending this class here. Thank you.